All right, so in this video, this is a lab video, okay, in our class, Machine Learning for Cybersecurity. All right, so in this video, we are going to focus on malware. All right, and so I'm gonna talk a little bit about malware, some of the ways that malware is classified with respect to machine learning, and then we're going to explore in the lab how we can deal with malware and extract features and do some machine learning. All right, so the learning objectives of this lecture are basically to cover, what is malware, so provide a definition of malware, and then we're going to look at the types of malware, how malware can be classified into some categories, types of malware, right? And then how you can, we're going to look at how you can use machine learning, so apply machine learning to malware detection. In the document, in the lab report or the lab handout, there will be some references to a paper or a couple of papers on malware detection with machine learning. All right, so the first thing is, so what is malware? All right, so what is malware? All right, so as we know, malware is just code, it's just software that does something, right? So the code gets on your computer or it starts spreading through a network, and the code can do some, bad things, steal your, consume resources, or maybe steal information, etc. Right? So, basically perform some kind of an attack. So it's code that performs some type of an attack. Now there are many classifications of malware, like viruses and things like that, computer worms. This class is, this lecture is not really about that. So I assume that you have some sense of that, right? So of the classifications of malware in that sense. My classification will be more in regards to how we can detect malware, right? So what are the types of malware? So we know it's code. So basically that means it's some kind of a file, right? So malware is some kind of a file. Now this is what's important for us in terms of machine learning, is that this file could be either static or it could be dynamic. So if malware is static, that just basically means somebody copied a file. So you have a file in your file system. So file in the file system. And the file, when you do your analysis, your detection, the file is not doing anything. It's just sitting there. So it's just a static file. The other classification is when you think of malware as a file that is dynamic. All right, so a dynamic file would be a file, that is, so file.exe, right? So something like that. So the file is a kind of executable file, and this one can also be an executable file, or it's attached to an executable file or something like that. But here, the difference is the file is not doing anything, whereas in dynamic, the dynamic classification, the file may actually be doing things, so it's running. So that's the key difference. So here the file is running, and here the file is not running. Okay? So that's the difference in what we're going to look at. All right, so let's then go over here. So we have malware, right? And we know that we have, it's basically a file. One file is static, one file is dynamic. So this one is static, this one is dynamic, which basically means this one is not running. So this one is not running, and then this one over here is running. So one is not running, one is running. So that's then, how do we detect for these? All right, so obviously we all know about malware detection systems. So for static, like antivirus scanners, so antivirus, right, scanners. So they basically do something, what is called a hash approach, right? So they hash the files, so they hash files, all right? And that's, from crypto, right? So cryptography, the, hashing functions basically, which take any file, of any length, M or whatever, variable length actually. So these are variable length files, right? And then they go through a hashing function, and this is f, of course. So this is a hash function, and then it produces a fixed length variable. So variable length here is variable length. This is fixed length variable, which is a hash basically. And so as we know, when we have hashing functions, that hash is unique, right? So mostly. So there could be some collisions, but in general, depending on the algorithm, here we're talking about like SHA 256 or one of those, right? So when you have that type of an algorithm, it's going to, for every file in your file system, is going to create, the corresponding hash. Usually it's going to be a fixed length variable that is unique. So basically, if you've identified a virus file, then you hash that file, and then you hash all the files in your file system. You look for it. So let's say here you have the file system, right? And then you've hashed all the files. So hash 1, hash 2, hash 3 of all the files. Then you have a virus hash of malware, right? And so, you check this one, you check that one. You're checking all of these against that. You're going to say, well, this one does not match. That one does not match, but as it turns out, this one matches that. All right, and so when you do that, there's a match, and so that basically means you found a file in your file system that matches the hash of malware, known malware, and so therefore you can detect it, right? So that's the standard approach that we have. So that's one static approach. So let's say static hash. Now, there is another approach where it's still static, but now we can use something like machine learning. All right, and this is actually very similar to document classification. So let's think of this one. So I'm just going to say here ML. And then for dynamic analysis, when the code is actually running, you can. I will just go directly and say we could also do machine learning. So they're basically based on this classification of static and dynamic, we can apply machine learning to both areas, right? And one of the interesting observations about this, and there are many ways of doing this, by the way, but one of the interesting observations, at least that I've seen, is that you can think of malware as a natural language processing problem, so as an NLP. Because in document classification, for instance, what we have is we have files of words, right? So we have files of a whole bunch of words, and those are static, right? But in malware, what do we have? We also have files. We have another file over here, and the file consists of things, right? Whether it's like binary things or whether it's actually the text of the file, right? You have this. So if you look at them, they're very similar, right? They're both made up of a vocabulary of terms. So these are obviously terms from the English language, or any language, right? So these are language, whereas this is just the technical terms of a file, right? Like code, for instance. So we could say code, whether it's assembly code or actual C code or something like that. It's still at the end of the day a vocabulary of words. Now, as it turns out, this is for the static approach, but we can also do the same for the dynamic approach, because in the dynamic approach, what we can do is we can run the program, right? So we can run the program in an emulator, and then we can log. So we can log everything that program is doing. So all the registry edits, or all of the reading of files, making internet connections, etc. We're calling DLLs, etc. So all of that becomes a log, which is also a file made up of, again, a vocabulary. This time not of the code itself, but of the things that the code is doing. So once again, this file can, in essence, have its own vocabulary and a language. And so this is really, based on this observation, our lab, will consist of this approach. There are other approaches out there, of course, but we're just going to look at this one. All right, so let me summarize over here then. So again, we're still, we're talking about malware. I kind of gave an introduction of how malware is usually detected through hashing functions in a static way. In our approach, we're just going to look at machine learning, all right? But we're going to classify malware as being static or being dynamic. So static, right, or dynamic. And we are basically going to learn a procedure that applies to both, right? So remember that the machine learning pipeline basically says that you get the data. So you get the data, right? Then you clean the data, right? Then you do the feature extraction, right? So the feature extraction, all right? And then you do some kind of machine learning, right? And then comes the evaluation. So as you might imagine, the machine learning part here is still pretty consistent with everything else we've done. We can use something like, something easy like Weka, right, or TensorFlow or sklearn, right? So, but in this set of slides, I am mainly going to focus on the feature extraction. So how do you do it, right? And so the way that we're going to do it is we're going to treat malware as an NLP problem, so a natural language processing problem. All right, so now that we have that framework, so the idea is we either have a file, as I said, which is the malware, .exe. It's made up of words, some code, assembly, or something like that. We assume those are words, so we apply a natural language processing technique, and we obtain the feature vector, right? The other approach is to think of this as dynamic. So again, we have the same file, right, .exe. It's got its own code, right? We are going to run this file in an emulator, like ZeroWine or one of those, right? So emulator like ZeroWine. So what is an emulator like ZeroWine? It's basically just like a virtual machine, Windows virtual machine, let's say, where you run this executable file. So it's got its own memory and and everything, but it's a sandbox approach. So it's it doesn't affect anything else. You run the program from beginning to end, and while it's running, you're going to log everything that it's doing in this sandbox. So you now create a separate file called a log file that keeps track of everything, right? So it keeps track of all the log entries, right? Everything that it's doing, all its internet connections, all right? And then once you have this log file, then again, you treat it as a file made up of a whole bunch of words, just like an NLP, like a document. So you apply, NLP techniques, right? And then now you obtain basically some kind of a feature vector. Right? And that feature vector is what you're going to use for your machine learning analysis. So here I can just say machine learning, okay, and then machine learning. All right. So now that we understand the theory, let's just think a little bit about the scenario in the lab. So we have a lab, right? And in this lab we have, let's say, 50 samples of, 50 files. So we have 50 executable files, let's say, so .exe file. So I believe these files that we have in our lab are from Bad Rabbit, malware, and something else. So it should be described in the document. And so let's say we have 50 files here, 50 of malware, right? So Bad Rabbit, other kinds of malware, and then here we have goodware, let's call it. And goodware is just like running, the calculator, the browser, so something like that. Any programs that you would just use for your own programs. And then here, I'm just going to write Bad Rabbit, all right? And some other malware, just say malware 1, etc. All right? So these are the programs that we obtain in our lab. So remember, this is all dynamic. So we are going to take, in a loop, right? We take all 50 files, I should say that this part of the lab is already provided for you, right? So we already took, let's say, 50 malware. We ran them through an emulator, and then the emulator produced 50 log files of everything that the file did, right? So that includes DLL calls, it includes, registry entries, accessing files, etc. Right? So these are all usually the tasks that these files are going to do. Right? So again, we took the 50 malware, we ran them through the emulator, right? So we ran them through the emulator, and now we end up with 50 log files. Each log file matches to one malware, right? And it's basically a text file of all the steps it takes, right? All the entries. All right, the next one is, we also did this for goodware because this is going to be a supervised, so we're going to do some machine learning, right? And it's going to be supervised learning, which basically means that we have labels, so supervised learning. All right, so we take 50 goodware, right? Again, we run it through the same emulator. Imagine like a Windows environment that we're creating. And then this emulator is going to produce, once again, 50 log files. There's actually 142 files in the lab. So the lab has 142 files. But I'm just using this number like 50-50. It's still going to be pretty balanced. So it's 50 log files. Again, this will record whatever the goodware is doing, calling DLLs, files, registry. So as you might see now, the goal of machine learning is to find differences, right? So for instance, it might turn out that on average, malware always calls DLL23. Let's just say that. This is a common thing that you see here. The frequency of this is really high, high frequency, let's say. And then DL23 in goodware is very low. The frequency of that is really low. So that's not the actual case, but that's an example, right? So remember that in machine learning, what you're looking for is for every feature, you want to see a pattern where it's very common, it's frequent for one set of features, but infrequent for the other set of features. All right, and so this is our lab scenario, okay, our lab scenario. So basically then, to solve your lab, you're going to have a directory, so you have a folder with, let's say, 142 files, all right, of these 142 log files. Each log file will have a name, so it'll be like, let's say, good 1, right, .log or .txt, then you're going to have another one that's going to be good 2.txt, right? And again, here are all the entries, right? So DLL 23 something, and then, other stuff, registry something, etc., right? So you have all this information from the dynamic behavior of the file. Then you have over here, in that same folder, mal1.txt, mal2.txt. All right? And so this is what you're going to end up. So as you can see, each one of these log files represents one file that you ran in the emulator. One, either a malware or a goodware. So each one of these then, if you think about it, is a sample. So this is sample 1, sample 2, sample 3, sample 4, right? And so each one of these, when you think of the machine learning matrix, X, right, and your labels, right? So you have X and Y. The Y's here, these Y's need to come from this. So you need to extract from the name of the file the label. So this is a goodware, this is goodware, and then this is malware. This is malware, right? So those will be the labels that go here. So I'm just going to say good, mal, and so on. So those are the labels. The name of the file is the labels. And then you have to take this entire content of the file, treat it as a document, and use NLP techniques to extract. So this is going to be sample 1, so S1, S2, S3, S4. So you basically need to take this entire thing, this entire thing, and make it into a row over there. Then you need to take this one over here, and that's going to be, sample 2, and so on, right? So you need to convert those into vectors, vectorized somehow. All right, so that's what we're going to do. So how are we going to do this? We are going to actually take, if you think of this as a document, so if whenever we have a set of documents, we convert it into words, right? So we say the car, dog, in car, doghouse, right? So this is called the bag of words approach. So that basically means that we are going to define a vector space made up of all these words. Notice that our vocabulary here is very limited, right? It's only made up of the car, dog, in, house. And of course, we could have more words if we had a bigger vocabulary. So we have 3 files. So it's sample 1, sample 2, sample 3. All right, so now we're going to add entries here. And so what we have to do now is we have to represent sample 1, sample 2, sample 3 based on this vector space. Vector space called bag of words. All right, so what do we know about sample 1? Sample 1 has the word the and the word car, and it does not have the other ones. Then we have dog in car, and dog, so that has this one, and that one, but it does not have these 2. And then doghouse has this one, and it has this one, but it does not have these. And so that is the vector space approach. The vector space approach can also do a count, so it could be the car the, in which case the here would actually be count of 2. All right? And so this is what we want to do with the malware. So imagine this is malware 1, malware 2, goodware 1. So now instead of these words, it could also be, let's add DLL 23 here, which appears also in this one, DLL. This is a very simplified example, and then here we have DLL 85, let's say. All right, so now we can add DLL 23 here and DLL 85. All right, so now we have those 2 additional words in the vocabulary, and what do we know about them? DLL 23 appears in this one and in this one, but not in this one. And then DLL 85 does not appear in the first 2, but it appears in that. All right, and as you can see, we want to take our files and represent them like that with a bag of words approach, right? So we want to take the bag of words approach. Now, so once we do this, once we have done this, then we are ready for machine learning. This is the feature vector space. This is actually perfect for machine learning. As you can see, our machine learning algorithm would learn because it has the labels MM, so that's the labels are here, M, and then the last one is goodware. So it would learn, okay, well, whenever I see car, it's associated with malware. Here I can't really tell much, so nothing much to guess there or to learn there. But there's also this, right? So DLL 23 seems to be associated with malware because it's not here in this one. Whereas DLL 85 is associated with goodware, it seems. And so anyway, so this is how machine learning could learn to distinguish between goodware and malware from the log files that you obtain through dynamic, through running the executables, right? So dynamic analysis of malware. All right, so that's, hopefully that makes sense. That's the general approach. And so what we're going to do now is we are going to focus on how to write the code that can take our log files from that to, this, right, to the vector space. All right, so for this we're going to use something called count vectorizer in Python. All right, so in summary here, we've learned a little bit about malware. We learned how to classify for machine learning purposes malware into static and dynamic. analysis. We learned that with dynamic, we can use log files of the actions taken by the virus itself. Or we could just look at the file itself, right? So code itself. Or the log of the action, let's say. So log of actions or behavior of the malware. Right? And then we learned that we can model, we can take these log files, you can think of them as documents with words, and if you do that, you can process them basically as if you would process NLP through a bag of words approach. Right? And that can then give you, based on this, you can obtain the vector space model. All right, so that's what we have learned in this slide. So the next video about this topic, about malware, will be the code in the lab to do the feature extraction.